Hello and welcome back to our lecture series on superposition theorem. So in the previous part, we've looked at what superposition theorem is, more like an introduction, and we explained what the concept is all about. So right now we are going to be looking at the first example explaining superposition theorem. So now let's look at what we are having here. It says, now this is the circuit that we are going to be working with, and the question says, determine the current through the 20 ohm resistor using superposition superposition theorem. Exactly. So you can see, just like I said in the previous part, that the question sometimes might tell you specifically that you should use superposition theorem. Now if you look at the circuit we have on screen, you can decide to use maybe mesh analysis or nodal analysis, exactly, to get your answer straight away. But since the question is telling us that you should use superposition, and that is what we are going to be using here. Alright. So to start with, like I explained, if you are dealing with superposition theorem, you are going to be having more than one source, either a combination of current and voltage source, or just only current or only voltage. But if you look at this that we are having on screen now, we are having just two voltage sources, and both of them are both voltage source. So now let's start by considering one voltage source at a time. So here I will say, considering the 6 volts source. So since I'm considering the 6 volt source, so I'm going to be redrawing the circuit. Is going to look like this. So doing that, we are going to be having, so I can also represent my resistance like this. So I have to make the longer part. Now, for this 12 volts now, what we are going to do, since it's a voltage source, what do? We short circuit. So in short circuit needs, we are just going to be having a link through it. So this is our 10 ohms, 10 ohms, and then our 20 ohms. Are we good? Alright. So now, and this is our 6 volts. So now we can go ahead and calculate the current that is flowing through this 20 ohms resistor. So in doing this, I'm going to be using the mesh analysis, which is more like the KCL, sorry, KVL rather. So what I want to do now is, let me take my current direction for each of the mesh. So let me take this direction, that's okay, for I1, and let me take this direction for I2. Okay, so based on the current direction I'm picking, so that means this will be positive, negative. So positive, negative. Based on this clockwise direction here, this will be positive, negative, positive, negative. Then for that of the voltage source, it will remain constant. From the question, we know that this is the positive and negative side. Exactly. So now so at mesh 1, so I'm taking this to be my mesh 1, and I'm taking this to be my mesh 2. Are we good? So if at mesh 1, apply KVL. Exactly. So if you should apply KVL to mesh 1, so if it is going in this direction here like this, so we'll be having minus 10. So let me change mine. So that will be minus 10 I1. Exactly. So if you don't understand what I'm trying to do now, I would just encourage you to also try and watch the video on mesh analysis that I did previously also. So that will be minus 10 I1. So in this direction also, minus 20 I1, also plus 20 I2 equals to 0. So let me just explain what I did here. So in this direction here, like this, so like I said, I'm considering this as my mesh 1. So in that direction, if it is going like this, this is from positive to negative due to current I1. So that's I'm having 10 and minus 10 I1. That's from positive to negative. So that's how I got that. Then moving away from that, I'm coming towards here. So from positive to negative here, so that will give me minus 20 I1. Also from negative to positive due to I2, so just take note, that's why I'm having plus 20 I2. So that is it on this particular closed part equals to 0. Are we good? So if I should simplify this, now I'm going to be having minus 30i1 plus 20i2 equals to 0. So let me call this my equation 1. Okay, so then let's continue. So let me say at mesh 2 also we also apply KVL. So if we should do that in mesh 2, we can just start from any part of it. So for mesh 2, so let me just start from positive to negative in this same direction like this. Exactly. So that would be minus 20, that is due to I2. Also from negative to positive due to I1. So we are going to be having plus 20 I1. So we are done with this resistor here. So now let's come over here. So from positive to negative. So that would be minus 10 I2. And then if you should continue in this direction towards the voltage source, we are having positive to negative. So that would be minus 6. Exactly, because we already have it in volts and equals to 0. So if you should simplify this now, we are going to be having 20 I1. So we are having minus 20 I2 and minus 10 I2. So that will be minus 30 I2. So this minus 6, if you take it to the other side of the equals to sign, that will be equals to 6. And this would be our equation 2. Are we good? So now what we want to do is to solve our equation 1 and equation 2 simultaneously. So let me continue here. So we write solve or solving equation 1 and 2 simultaneously. So that's minus 30 I1 plus 20 I2 equals to 0, and 20 I1 minus 30 I2 equals to 6. So you can just make sure you show your calculation is solving the simultaneous parts of the equation. I'm going to be doing it here, even though I intend on doing it just to save time, but let's just do it together. Alright, so if I'm to solve this now, simultaneous equation, so let me multiply this by 20 and then multiply this by 30. Exactly. So doing that, we are going to be having 20 times minus 30, that will be minus 600 I1 plus 400 I2 equals to 0, and then 30 multiplied by this is going to give us 600 I1 minus 900 I2 equals to 0. I know you can use your calculator, but if you are solving this theoretically, make sure you show these workings also. So this can cancel this, and then so that means if we add this up here, so that means we are going to be having 400 minus 900, so that will give us, remember we're having plus 400 plus minus 900, so that will give us minus 500. Oh, sorry, I mixed this part. So 6 times 30, that's 180. So let's continue. So minus 500 I2 equals 180. So that means our I2, so our I2 will be 180 over minus 500, and that will give us, so let me type that in my calculator and see. So 180 divided by 500, so that will give us minus 0.36 amperes. So that's our I2. So that means our I2 is minus 0.36 amperes. So now that we've gotten our I2, so we can use that to get our, hope you are following the sequence with the space I'm using to solve the question. We started from here, started from here and then we continued here. Exactly. So now let me move over to this space now. So let me substitute the value of I2 into any of the equation, either equation 1 or equation 2. So let me just use the second equation. So that means we are having 20I1 minus 30 into bracket. So we know our I2 to be minus 0.36 equals to 6. So that means we are having 20I1 plus, so that's 30 minus 30 times minus 0.36. So that will give us 10.8 plus 10.8. So we are having negative here, negative here. So that's giving us positive, exactly, equals to 6. So if you should do this now, that means our I1 is equals to 6 minus 10.8 divided by 20. And if you should do this, now we are having 6 minus 10.8, that will give us 4.8 divided by 20, and we'll be having minus 0.24 amperes as our I1. So that means our I1 is minus 0.24 amperes. Okay, so now let's use this. We've gotten I1 and I2, but what we actually need is the current that is flowing through the 20 ohm resistor. Okay, so now let me write what we are having here. Let me draw it out here. So there we are having something like this, and this is our, so let me do it again. So we are having our 20 ohms resistor, right? And we are having two currents is actually flowing through it, I1 and I2. So based on the direction that we assume for I1, a clockwise direction like this for I1, and then for that of I2 also, we also took a clockwise direction, which is also like this. So this is our I2. So if this direction continues like this to this point, we are going to be having it like this, right? And if I2 also continues in this its own direction, we are going to be having it upward, exactly. And then don't forget the polarity based on the current direction. So this will be plus, minus, and this will be plus, minus. So you can see that was how we got the direction here. Okay, so now for you to now get the exact current that is flowing through 20 ohm resistor, remember we are still considering the 6 volt source. So for us to get the current that is flowing through this 20 ohm resistor, what we'll actually do is we will look at the value of I1 and I2. Exactly. So the one that is higher, exactly, minus the one that is lower. That's how we are going to get the current. So let me write it. Let me represent it with current flowing through the 20 ohm resistor. So if you look at these two values, I2 and I1, which one is much higher? We are having 0.36 amperes and minus 0.24 amperes. So we are minus 0.36 amperes and minus 0.24. Which one do you think is higher? Okay, so because of the negative sign, minus 0.24 is higher than minus 0.36. So what we are going to be having is I1 minus I2. So in doing that, our I1 is minus 0.24, then minus 0.36 amperes. So if you should do this now, this is going to give us minus 0.24 plus 0.36, and that with that we are going to be having our current through the 20 ohm resistor is 0.12 amperes. Now take note, that's not our final answer. What we've just gotten is the current that is flowing through the 20 ohm resistor due to the 6 volt source. Exactly. So what we want to do again now is to calculate the current that is flowing through this 20 ohm resistor because or due to the 12 volt source. Exactly. So what we will do again now is to repeat the process considering this 12 volt source. All right. So one thing also you need to also pay attention here is the direction of this current. So since it is I1 minus I2, so that means it is more of I1 that is flowing through it. So our direction is going to be the same direction with I1. And don't forget the I1 is in this direction. Exactly. So you need to take note of that. So let me write it properly. So that means current through the 20 ohm resistor is 0.12 amperes towards this direction. Exactly. Because this is our I1. You can see our I1, the direction is downward. So you need to take note of it because this will also help you in getting your final answer. So like I said, now let's go ahead and draw the circuit again considering. So let me go ahead and draw the circuit considering the 12-volt source. So in considering the 12-volt source, we are going to be having a circuit that looks like this. So that's the first resistor, the second one. Then, so the 12 volts is somewhere here, so we can bring it back. So now we are not going to be considering the 6 volts, we are going to short circuit that. Exactly. So here we already have our 20 ohms, and then at the top, okay, they are both 10 ohms. So this will be 10 ohms, 10 ohms. Okay, so now we are going to repeat. So let me 12 volts. So now we are going to repeat the process again, just like we did for the 6 volts. So let's take this to be I1 in the clockwise direction, and let's take this to be I2. Remember, I'm using mesh analysis, and I said it, you can decide to use mesh analysis, node analysis. You can even use the current divider rule or voltage divider rule, depending on the nature of the circuit. Exactly. Okay. So in doing this now, so let me pick my polarity. By virtue of the voltage source, this is plus, this is minus. But since the current direction that we've picked, so we'll give this a positive, negative sign. For this now, this will be positive, negative, while for this part, we are going to be having positive, negative. Exactly. So if you're not clear on the polarity, I'll just encourage you to watch the video I did on mesh analysis. Alright, so since we've given, okay, so this will be plus and minus. So now that we've done giving the polarities, so let me go ahead and write apply KVL to mesh 1. Okay, so let me just start that from the left side of the screen. So apply KVL to mesh 1. So in doing that in a clockwise direction like this, so we are going to be having, let's start from here. So that will be 12 volts. So from negative to positive, so we are going to be having 12 volts. So let's come over here from positive to negative. So you can see from positive to the negative. So that will be 12 minus 10 I1. Then from positive to negative for this side here. So that will be minus 20 due to current I1. Also from in this same direction from negative to positive due to I2. So that will be plus 20 I2. So we are done with this particular close part equals to 0. So let's tidy it up. So this will give us minus 30 I1 plus 20 I2 equals to, so if this minus 12 comes to the other side, minus 12. So let's call this our equation 1. Okay, so let's also apply KVL. So we say apply KVL to mesh 2. So if you should apply KVL to mesh 2, so let's just start from this 20 ohms resistor. So from positive to negative, so that will be minus 20 I2. From negative to positive due to current I1, so that will be plus 20 I1. And then, so from positive to negative through the 10 ohms, So we are going to be having minus 10i2 then equals to 0. So if you should rearrange this, so that you'll be having 20i1 minus 30i2 equals to 0. So this is our equation 2. Okay, so again, what we'll do now is we are going to solve equation 1 and 2 simultaneously. So let me write our equation 1 is given to be minus 30i1 plus 20i2 equals to minus 12. And then our equation 2 is 20i1 minus 30i2 equals to 0. Okay, so just to save time, I will not be showing the workings for this, but make sure you go ahead and solve it. So I won't be showing you this, but you can the process of calculating this using simultaneous equation. So but if you solve this now, you'll be getting your I1. So like I said, please make sure you show your workings. I'm just trying to save us time. So if you solve this now, you're going to be getting your I1 to be equals to 0.72 amperes, and then our I2 is equals to 0.48 amperes. Exactly. So I also need to mention it here that you will notice that, okay, I wanted to say something, but I'll say it towards the end of the video, so that let's still continue. But like I said, do make sure you show your working. Don't just use your calculator and drop in your answer. Okay, so now let's go ahead and use the value of I1 and I2 to get the current that is flowing through the 20 ohm resistor. So now let me go ahead and draw it again, so that just like I explained the other time. So we said the direction of I1 is like this, and then for I2, this is for I2, right? So with that means, so this is our 20 ohms. So that means for I1 is coming towards the downward direction, and then I2 is flowing through upward. So here we are going to be having plus, minus, plus, minus. Are we good? All right, so now that we've gotten our I1 and I2, so how do we now get, because like we're having here, there are two currents that are flowing through the 20 ohm resistor. So how do we now get the equivalent? So again, I'm going to say the IF's value minus the lower value. The higher value minus the lower value. So if you check what we are having here, you can see that again our I1 is higher than our I2. So that means the value of the current that is flowing through the 20 ohm resistor when we are considering the 12 volt source is equals to I1 then minus I2. So this looks similar to the first one, I1 minus I2, but it's not in all cases. Some cases it might be I2 minus I1. Exactly. So that is when they are flowing in opposite direction. But if based on the polarity that you choose is the same direction, exactly, then you are going to be adding them up. Are we good? So I've explained all of this on the video I did on mesh analysis. So now let's continue. Our I1 minus I2, that will be 0.72 amperes minus 0.48 amperes. Okay, so if you should do this now, you are going to get 0.24 amperes. Exactly. And don't forget the direction, the one with the higher value, we are going to take that direction, which is downward direction. Okay, so now we've gotten the value of the current that is flowing through the 20 ohm resistor. Okay, so now let me write this here that, so the current that is flowing through the 20 ohm resistor due to the 6 voltage source is, we've gotten the answer to be, let me scroll back. So we've gotten to be 0.12 amperes in the downward direction. So that's 0.12 amperes downward direction. While the current flowing through the 20 ohm resistor due to the 12 volt source is given to be 0.24 amperes, also in the downward direction. Are we good? So therefore, now we can conclude. So So therefore, the current in the 20 ohm resistor will now be the sum of these two currents. Exactly. So we are going to be having 0.12 amperes plus 0.24 amperes, and that would be 0.36 amperes. And this here is our final answer, 0.36 amperes. Now, before we go, let me also explain something to you here. That's exactly. So the reason why we can also add it together is because you can see that they are flowing in the same direction. So assuming they are in opposite direction, what we did here, exactly, by subtracting, we are going to look at the higher value minus the lower value. That thing will also play out here. Exactly. But since they are in the same direction, you can just go ahead and add it. Exactly. And then you can also indicate your direction that is flowing in this direction. Exactly. So don't forget, I said that this is our final answer. But let's say, for example, we got the first value to be 0.12 amperes towards the downward direction. Exactly. This is just an illustration, please. We've already finished this solution here, and then we've gotten the second value to be 0.24 amperes in this direction. Exactly. So what you just do is the one that is higher. If you look at 0.24 is higher, so it will be 0.24 ampere, 0.12. Exactly. So that's because they're in opposite direction, and that will give us 0.12 amperes. Exactly. So this will be the case assuming we've gotten our first, considering the first voltage source, we have it in this direction, and then when we calculate the second one, we are having it in when they are in opposite direction. Exactly. You just pick the higher value, subtract the lower value from it, and this will just be the current that is flowing through that particular element or resistor. Exactly. So I hope you got the concept right. So with that, I'll see you all in the next video. But before you go, if this is still not clear, I will encourage you to make sure you go back and watch this example from the beginning. It is very explanatory. I know it might be long, but I took out time to make sure I explained. So just do make sure you watch it again, and again, you might need to watch it maybe 2 or 3 times. And if you have any question or any doubts, let me know in the comment section below. So this lecture series on superposition theorem continues. We still have many examples that we're going to be looking at. For example, this particular one, we only have this is more like a very simple form of example. We're going to be looking at, as we go higher, we're going to look at more complicated circuits, and we are still going to be simplifying them using superposition theorem. So thank you very much, and I'll see you all in the next one.